All right, so here is my app that I made, and this is used specifically to get the direction of what I'm pointing at. I moved the pitch roll yaw numbers down so that you can see them a bit better. But here's what's going on. So if I move the device to, let's see, right here, so there's pitch roll yaw of 0. In fact, let me put it on this table, and you'll be able to see that that's just about zeros across the board. We can get it to where it is. So you see that's down, and using this screen as kind of a VR portal, I need the 3D point to be directly below. And then of course, as I rotate the phone up, I'll get to, there's 45 degrees, and then here's 90 degrees, which is straight ahead of me. Now pitch does this odd thing where it goes back down to 0, but of course that can be corrected. But what I wanted to show you was that, for example, let's go to 90 degrees on pitch, and you can see that the roll wants to flip over as soon as you get to that, because like see, roll is 0, and it flips over as soon as you get to that, where you're pointing more up in this hemisphere. Whereas if you're pointing down, roll and yaw go back down closer to 0. Anyway, so if I go to 45 degrees on pitch, and I go to 45 degrees on yaw, I get down to there, which would be, the lower left corner. Let's see. Now, if I affect the roll, if I go to 45 degrees on the roll, I'm almost straight left, and this is a little bit tricky, and I suppose this is where the Euler Angle issues come into play. But looking at these numbers, I mean, this is what I've been working on, is trying to figure out how these all factor into the 3D space. And that's a little bit tricky. This is a little out of my expertise, which is why I've taken this to Stack Overflow. But hopefully these numbers help so that I can figure out how to map this all to 3D space. I'm trying to give you some more numbers here to see what's actually going on. At first I didn't think that yaw mattered, because that's just the camera orientation. But depending on where you're viewing, it definitely does matter. And man, I've been going back and forth with all the rotation matrices and trying to figure out how it's all put together. I'm not exactly sure. To mention more about my 3D space, in fact, I can pull it up with another app. And this is one that I've also got the source to. But for example, there's my model. It's a model of a bedroom, if you can see it. Of course I can zoom in and pan around them. And this is the one I'm wanting to do VR to. So, as I look to one side, it will go that way. Look to the other side, it'll go this way. Then obviously when I roll the pitch up, it will go like that. And when I roll the pitch down, it goes like this. But to try to make it feel more like you're looking at the actual room. Anyway, now this space is looking straight down at the room like we're looking now. That's the Z space. Going up in this direction is the Y space. And then, of course, left and right is the X-axis. If we go right, that's positive X. If we go up, that's positive Y. If we go down, that's positive Z. So it's flipped from what I put in my question. Anyway, that's what I'm trying to accomplish. So hopefully that information helps. Maybe you know what's going on, maybe you don't, but we'll go from there. Thanks.